So we discussed the properties of molding sand, then pattern allowance. Then let us know what are the molding tools. Molding tools means the tools which are required for making the mold. The screen is visible, isn't it?
Yes, sir.
Yes, sir.
So these are the different tools, less important from examination point of view. Mm. This is a reader, then shovel for taking the sand, then rammer for ramming the sand or compacting the sand. Then this is for leveling. Strike off bar is again for removing the excess of sand. Then vent wire is for cutting the small vent for gases to escape. These are all small tools like an artist or a painter use for painting. So like that, a lifter to lift the small amount of sand. Then slick again for trimming. Draw spike. Suppose if you want to cut small vent lines, then this spike is used. Swab is like a pump for removing the small sand particles. Then gate cutter, like with this you can directly cut the gate in the mold. So this now you are very familiar, but now this diagram will be useful for you if theory question is asked, like explain the green sand molding procedure. So that time your animation or your videos, your photos will not be helpful. So these images you can practice green sand molding procedure. It will be for 5 marks or 10 marks. So initially, uh, this portion is called as the track, which is resting on the floor, and this is a pattern is kept. Then surrounding the pattern, the sand is inserted. So similarly, you have this is your drag. Similarly, you have cope. Cope is also called as the core. So in this case, the product is symmetrical. So initially the cope and drag will look same, but how to identify the cope part or the core part? The cope part will have sprue and will have riser also. What is the function of the sprue? Of course, now in this figure it has been made ulta, and then similarly we have cope. So cope is kept, it is aligned properly with these pins, and the sprue is a passage through which the molten material is poured. And here the gate is not shown, but it is understood like this is a gate which is cut once the sand is rammed surrounding the pattern. Usually the gates are very small. Usually you have the feed system is you have a sprue, then you have runner, and then runner is connected to the cavity through small passage which is called as the gate. So this is pouring basin through which the metal is poured. Then you have sprue basin. Then you have small gate here, and gate and sprue basins are connected through a long passage that is called as a runner. So usually runners are long, broad, wider, and gates are very small. Why the gates are small? Because if your product should be de-gated. De-gated means what? That gate has to be removed very easily. Means you with a little pressure or with a little chop, you should be able to remove the gate so that labor is reduced. Otherwise, you will have to cut the gate with the saw or with the grinder. So that is an additional effort. Then there is a software like mold flow analysis which gives you what is the sprue size, what is the runner size, what is the gate size for a particular amount of material to be filled inside the cavity. Now here there is a mistake. Now there is no pattern here. Okay, the pattern is removed, so there is a hollow cavity here. Now the function of the riser is the excessive molten metal is lifted or is passed through a passage, and that passage is called as the riser. Like suppose you have calculated that volume of the molten material which is required is say half a liter or 500 ml. So usually what we do, we don't exactly pour 500 milliliter. So we may pour 600 because there will be some material during in the passage, in the runner, in the gate, in the pouring machine, because this is sand molding. In case of injection molding, you can control the material which is to be injected. So there you can have good degree of precision. But here we have to add extra material. So that's why in injection mold or die casting, you don't have riser. But here the riser is essential because now 500 ml is required. You are pouring 600 ml. Some part will go here, and the excess molten material will rise up through the passage which is called as the riser. So this riser, gate, runner, pouring basin, these are all waste, scrap, which has to be chopped off once the casting or once the product is removed from the mold. Anybody is waiting? So what are the basic materials and equipment for green sand? Now what is the meaning of green sand casting? Can anybody guess? Anyone, whatever you feel. No need to.
Green sand is used.
Yeah, green sand is used. That's why hmm, the name green sand casting. So of course the pattern is required. Then sand which is mixed with the clay binder and water plus some coal dust. These we have seen. What are the these additives? Then a ladder or container, rammer for pressing the sand, and then of course your cope and drag. One part is drag, another part is cope. So to summarize, first you have to mix the sand. Okay. Then place the pattern. When sand is placed, then we are aligning the cope and drag. Before that, the pattern is removed so that there will be a cavity in the cope and drag. Cavity means there will be a hollow portion which will be created due to the pattern. Okay, and of course, if you are using wooden pattern, then the wooden pattern has to be removed so that you will get a hollow cavity in the mold. You can have additional tube or pipe for pouring the metal, and then you have to fill with the molten metal. Now you have to see that here you have to close it properly. These two, both the half. that is scope and drag. So many times these two are locked with the help of a nut and bolt. Otherwise, because of the liquid pressure, because we are pouring the excess of liquid metal, so it may happen that the liquid metal may ooze out from this parting line. This is from these parting surfaces where this hope and rock are joined, because the liquid will try to lift the upper part, that is coke part, and then material may ooze out from this parting line or from this parting surface if the weight of the coke is not sufficient. Now here the pattern is removed after cutting the sprue. So you will get a cavity here, and you have to fasten both the molds securely, then pour the molten metal. These are the steps. Then allow it for cooling, that is solidification. Then remove it. Now you have to shake it so that the component or the product will come out. So this is the product. Remember, the product will look like the pattern. Only the pattern size will be more and the product size will be small. You have to shake or you have to break the sand in order to remove the component. So this is sand casting is basically simple, economical, cheaper, but it is laborious. Once the casting is removed, you will notice that the surface is quite rough. The sand is adhered to the surfaces of the product or the component or the workpiece, whatever you say, which has to be cleaned. So that is what is called as the cleaning and finishing or trimming process. So the very basic process to clean is called as the short blasting. So in short blasting, what we do, it's a kind of a machine. It's a drum. There is a drum here, there, a hollow drum, in which these castings are kept. Maybe depending upon the capacity of the drum, 50 castings or 100 castings, they are kept. Or if it is a huge casting, then maybe one or two castings they are kept in the drum, and then sand particles, uh, or the sand balls, or sometimes even the steel balls, they are thrown across the castings or across the workpiece with high speeds, so that the sand which is adhered to the surfaces of the workpiece is removed. The care is taken here that the sand balls or the steel balls should not damage the surface of the workpiece. So the pressure with which the sand balls is injected or the steel balls are injected has to be sufficient to remove the sand from the workpiece. At the same time, it should not be excessive that it will create khadda on the workpiece or it will damage the workpiece. So those has to be softer. उसका जो hardness रहता है sand का और steel balls का has to be softer than the workpiece. At the same time, the velocity with which it is striking the surfaces of the workpiece has to be controlled properly. And this shot blasting or sand blasting will remove the excess of the sand. But the sprue, runners, gates, that you have to cut by the saw or by the grinder. or by hammering. You can also use the process which is called the chemical dipping, so in which the castings are kept in a chemicals, so the foreign particles or the external particles surrounding the surface of the workpiece can be eroded. But this is not useful for very rough castings. So if the sand particles which are adhered in huge amount, it has to be removed by shot blasting or by sand blasting. If it is, there is a difference between sand blasting and shot blasting. So don't mix up. In sand blasting, sand is used, sand balls or the sand particles are used to remove the or to clean the castings. And in case of shot blasting, steel balls are used. Now core, you know that it is used for creating the hollow. So there is a separate procedure for making the core also. So again, cores are you made of sand, like your mold. Mold is made up of sand. So similarly, core is also made up of sand. So if there are holes in your workpiece or in the product which you are seeing in the video, then those holes can be created by inserting a core inside the mold. Now cores are made separately, sand cores. So for that again you will need a pattern. So same procedure. So for that again same procedure is used. Like we use the sand molding procedure. So similarly same procedure is used for making the core. So a pattern is prepared, and with the help of the pattern the cores are made. Now in order to support the cores in your sand mold, you have to create some extensions like this. So those extensions or those supports are called as the core print. Those supports, and this you have seen in the video. Those supports are called as the core print. So these are the requirement of the core. They should be strong to retain its shape, permeable to allow the gases to escape. It should be refractory so that it can withstand the temperature. So this you can read it. I already uploaded. Then core sand. Again, different type of sand is used for making the core. Sand containing more than 5% of the clay are not used for the cores. This is the most important statement for core sand. जो भी सैंड में 5% के ऊपर clay है, that is not used for making the cores. So this is what the sand is: zircon, olivine, carbon, sand constituents. These are the binders which are used, and these are the different type of cores. Just have a look on this. I will join you in a minute. Yeah. Have you understood this type of the course? Hello?
सर द लास्ट वन
Yes.
विच हैज टू सेपरेट वर्टिकल बाइंडिंग्स
Okay.
वो जरा समझा दो.
अच्छा, ये horizontal core है. Okay. This is vertical. What is the purpose of core?
To create the hollow.
Yeah, to create the hollow. Okay. Then you have a balanced core. Then fourth one, that is cover core. Then hanging core with the help of a small wires. Then wing core. I will zoom it. Then ram up core. And this last one, this is what you are talking, isn't it? Hello?
Yes, sir.
Yeah, so
The
these are
last.
so these are called as the kiss cores because they are kissing the sand little bit here. This. So this is one core and this is another core. These are the two cores and some part is going inside this sand. See, can you see this shallow cavity which acts as a support to this core? And similarly, you can see a small cavity. hmm, uh, what do you say? This will be concave shaped cavity which is sunk inside this sand which acts as a support. So this is basically two cores only, and they are called the kiss cores because they are just touching the sand. So there will be two hollows in this. I hope it is clear.
हाँ सर.
Hello. Okay. लेट ज्वाइन किया.
हाँ सर थोड़ा लेट हो गया. Sorry.
No
What
problem.
happened?
Yeah. So there is a procedure in core making. You have to first prepare the core sand, then core molding, then baking. Baking is important. Baking is important. Only what now here the core is made out of sand. Okay, so it has to be strong, isn't it? So that's why it is heated, so that it will have a good strength. And when these cores are kept in the sand molds, they doesn't collapse. So that's why baking का मतलब हम लोग हीट करते हैं जैसे कि केक बनाते हैं. एंड देन यू हैव टू फिनिश द कोर अगर रफ सरफेस रहेगा तो. Then how to prepare the core sand? Mixing of the core sand should be homogeneous. Homogeneous means having the same properties throughout. जैसा कि हम लोग सब्जी में नमक डालते हैं, so it should be homogeneous. हम लोग उसको स्टर करते हैं सो दैट दैट सॉल्ट गेट्स मिक्स्ड thoroughly. Now green sand cores are made by ramming the sand mixtures into the two boxes. So जैसा कि हम लोग वर्कपीस के लिए जैसा सैंड मोल्ड बनाते हैं, तो सिमिलरली हम लोग कोर के लिए भी काइंड ऑफ अ मोल्ड बनाएंगे इनटू टू बॉक्सेस. ओके, और इनसाइड we will cut a cavity of the desired shape. Okay, so it's like a sand mold. फिर उसमें हम लोग क्या करते हैं, ramming the sand in those two in which the cavity is cut of the desired shape of the core, because it is not necessary that hollow should be round. It's a hollow and it can be of any shape. It can be round, it can be square, or it can be of any shape. Sometimes कोर के अंदर हम लोग वायर डालते हैं, स्टील का वायर, सो दैट इट गेट्स स्ट्रेंथ, जैसा कि कंस्ट्रक्शन में होता है. कंस्ट्रक्शन में जैसे कि हम लोग स्टील के रॉड्स डालते हैं कॉलम्स में और बीम्स में, सो लाइक दैट हियर inside the core we can put the wires in order to have strength, sufficient strength. Then once you get the cores, then you have to bake it to this. मतलब वो जो कोर जो हम लोग कोर बॉक्सेस में जो कैविटी पहला करते हैं हम लोग, so for making core also you will need patterns. With the help of the pattern you will make the cavity boxes. उसमें से हम लोग कोर बनाएंगे और फिर that core has to be removed and it has to be baked. Then you can do finishing and dressing up to get a smooth surface. See, now this is what is your core is. This is your core is. Now this portion is, this is your mold, sand mold. Now this portion goes inside the mold, which acts as a support. Now you will get a hollow in your workpiece. Now what happens when the molten metal is poured through this spool? This is a sprue. There is no guarantee that molten metal will flow equally. It will fill equally in both this hollow portion, because you know liquid always accepts the least resistant part or path. So wherever there is a least resistance, it will flow there. So there is no guarantee that molten metal, मतलब you have poured say 600 ml, so 600 ml से बराबर 50-50 एक साथ इसमें भी गया और इसमें भी गया. That may not happen. So if the liquid metal is going here first, so it will try to deflect this core. So ये bend हो जाएगा core. तो इसके लिए हम लोग उसको सपोर्ट लगाते हैं, and those supports are called as the chaplets. Now my question is, are you going to get this hollow inside the workpiece due to the chaplets?
No,
No. Why?
because they are made of the same material that
Yeah,
of the
good,
molten metal.
good, very good. So you have read this. Hmm. So what will happen? They are made of the same material. So what will happen?
So they will also melt.
Yeah, they will also melt. So you have to ensure that this chaplet material and the molten metal material is exactly of the same specifications. Then the gating system or feeding system. So it comprises of pouring basin, then sprue, then primary runner, then secondary runner, and then gate. So this complete is called as the feeding system. जैसा कि हम लोग का feeding system, it starts from the mouth and ends with the intestine. फीडिंग सिस्टम मतलब हम लोग मटेरियल मोल्टन मटेरियल फीड करते हैं. So you have to see that the scrap is minimum. That is what you have to ensure. There is a minimum scrap because this is going to be waste, and that's why we go for the injection molding technique or we go for the die casting techniques because there ये सब इतना झंझट नहीं रहेगा. Pouring basin, risers. So only one small sprue, then runner and gate. That's all. Whereas in sand casting or in sand molting, the sprue, runner, pouring basin will comprise at least 10 to 15% of the material. Means, agar suppose if the weight of the component is 1 kg, then pouring basin, sprue, runner and gate may be around 15% of 1 kg. That is around 150 grams. So 150 gram of wastage will be developed, which is minimized in your injection molding and die cast molding. So runner is usually a horizontal passage, and runner is again divided into two parts, that is primary runner and secondary runners. If it is multiple cavity mold. So the function of the runner is to connect screw and the gate. So riser is for the extra material. So sometimes it compensates also. Like suppose if the workpiece, if it needs some more material, hmm, and if you are stopped feeding the material from pouring basin, then from the riser, the molten material can be used for the workpiece. It's like a storage tank. And why it will be required? Because of the shrinkages. See, 1%, 2% shrinkages, these are just guidelines. Okay, but in actual, there are a lot of parameters which affects this shrinkage. The specifications of the material, then the processing parameters, then your mold dimensions. They affects So that's why these techniques, injection molding or sand molding or die casting molding, they cannot be used for very high precision components where we are talking tolerances of 20 microns, that is 0.02 millimeter, or there you have to go for machining only. Because in sand molding, injection molding, blow molding, there are limitations because the factors are many: temperatures, pressures, and they cannot be controlled precisely. Precisely means like I cannot control the temperature within plus minus zero point 0.1 degree Celsius or zero point 0.2 degree Celsius. Maybe it is plus minus 1 degree Celsius. Yes, I can. Then this is just for your knowledge purpose, not important from examination point of view. That is solidification of the castings. It takes place in two ways. One is called as the progressive solidification, and another is called as the directional solidification. So this is progressive solidification is perpendicular, and directional solidification is longitudinal. Okay, like this. This also you can skip because you don't have any mathematical models or formulas to be remembered. But those who are interested, those who like to know more, uh, they can always remember this, because as a mechanical engineer, you may choose foundry as a career also, mold making also as a career. So there, this formula will be useful. Like solidification time is proportional to V by A, the whole square, where V is the volume and A is the projected area. Projected area means top ka surface area. Projected area means how much is projecting upwards to that area. A. So chills, you just remember that can be used. Just a minute. Chills are used in order to improve the solidification. That is, if you want to make the solidification faster, then chills are used. Like suppose हम लोग आइस क्यूब्स यूज करते हैं, हाँ, पानी है, सपोज वाटर है, if it is slightly warm, the tap water, it is warm. So if you want to make it cool in a faster way, so what we do, we put ice cubes so that it becomes cool rapidly. So same is the function of chills. हम लोग बोलते हैं ना chill down means cool down. So same way the use of the chills is to solidify or to help the solidification in a faster way. We were talking about draft along. So draft is nothing but a taper. Like suppose if you don't provide a taper, if the portion is straight, then you will have difficulty in removing the pattern. Whereas if you provide a taper like this, then it can be removed easily. And you have seen in the videos that you are fixing up a small screw and then just pulling it up. Casting defects is important from examination point of view. 5 marks questions. What are the various casting defects? So This is self-explanatory. It is because of the following reasons: that faulty pattern design, fault in the design on mold and core. These are the reasons why the defects can occur. And these are the defects. Now defects are again classified into three categories, that is surface defect, internal defect and visible defects. सरफेस डिफेक्ट मतलब जो सरफेस के ऊपर दिखते हैं वो, लो इंटरनल डिफेक्ट मतलब अंदर, इनसाइड द वर्क पीस, and visible defects मतलब which can be seen very clearly. It is called the visible defects, and of course that will be on the surface, but then you don't have to see very minutely. It is clearly visible, like on the, suppose on the skin, if there is a boil, so that is a visible defect. But small skin defects hai, which we need to see carefully, that is a surface defect. And inside the body, if there are any defects like choke up or gas or stones, urine stones, then those are called as the internal defects. So same here, it is surface defect are this. These are the internal defects and these are the visible defects. So surface defects are due to the poor design and quality of the sand molds. And जनरल कॉज इज पुअर रैमिंग, मतलब हम लोग सैंड को बराबर दबाते नहीं है. दिस इज अ ब्लो, दिस इज कार, दिस इज ब्लिस्टर, दिस ड्रॉप, penetration, buckle. So these are the defects which will be seen on the casting on the workpiece. So every defect has been explained. So this is what is your blow is. It is relatively large cavity produced by gases which displace molten metal from the convex surface. Like say this is your convex surface. अभी यहाँ से इतना मटेरियल निकल गया, so that is what is your blow defect. There is also a defect called the blow hole. Blow hole का मतलब अंदर होल आएगा कास्टिंग का अंदर. We are talking about defects in the casting, defect in the workpiece. हम लोग मोल्ड बनाया, मोल्टन मेटल डाला, उसको सॉलिडिफिकेशन किया and we got now product. Okay, so इसमें इसके अंदर क्या क्या डिफेक्ट्स हो सकते हैं. So that is what we are discussing. Scar mark, it's a shallow blow, छोटा सा, which occurs on the flat casting. मतलब देखो यहाँ पे मेटल नहीं है, बार बार बता रहा हूँ, कास्टिंग मतलब जो मेटल का जो कास्टिंग अभी बन गया है उसके सरफेस के ऊपर इतना हल्का सा मटेरियल नहीं है. दैट इज द शैलो ब्लो, शैलो रिवर, शैलो पैसेज बोलते हैं हम लोग. तो सिमिलरली स्कार मार्क हमारा स्किन के ऊपर भी आता है, थोड़ा सा हल्का सा जख्म या सम काइंड ऑफ अ बंट मार्क on the body that leaves scar. Blister मतलब a scar which is covered with a thin layer of metal, that is this is called the blister. ड्रॉप जैसा एक प्रोजेक्शन आ जाता है, irregular shape on the casting, on the workpiece after the casting is done. After the casting is done, workpiece आपने बनाया, ठीक है. Now you are inspecting it. So these are the defects which can be seen. The scab. When an upheaved sand gets separated from the mold surface and the molten metal flows between the displaced sand and the mold. So this is because of the too fine sand. Penetration. When the molten metal flows between the sand particles in the mold. This. मतलब जो सैंड में है, सैंड में थोड़ा मोल्टन मेटल घुस गया और ऐसे हल्के से ऐसे जैसे कि हैक्सॉ का टीथ रहता है, ऐसा आपको टीथ मिल जाते हैं. दिस इज योर वर्क पीस और ये वर्क पीस के ऊपर के डिफेक्ट्स है सरफेस के ऊपर. बकल जैसा वी शेप कैविटी या डिप्रेशन रहता है, दैट इज कॉल्ड द बकल. आपका इंटरनल डिफेक्ट है. और मे बी we'll continue next time internal defects. All right. It is
Yes, sir.
too much. Okay. Thank you.
Thank you, sir.
Welcome.
Thank you, Sabasha.
Thank you.
Yeah. Thank you, Sandra.